All right, in chapter 5, we're going to look at linear functions, but we needed to review a couple concepts here. We're going to match the term with the graph. Some good reminders. Here's where my x-axis is. Here's where my y-axis is. My origin sits in the middle at 0, 0. When I talk about my vertical axis, I'm talking about my y-axis, and my horizontal is following my x-axis. A couple other terms is just being familiar with the quadrants. My first quadrant is the one we spend a lot of time in. It's positive and positive. My second quadrant is 2, so information here is positive, positive. Information here is in coordinates would be negative and then positive. Quadrant 3 is negative, and then down would be negative. And fourth quadrant would be positive. I'm going to the right, and negative would be down. So first quadrant is more for our optimist folks, and those that are just having kind of a bummer day, you are like third quadrant people. A couple more things, just how to plot a point, just to refresh our memory a little bit. X is talking about going right or left. We're doing it first from the origin, and then Y is telling us to go up or down. So I'm going to plot a couple things here just to bring us back here. So I'm going to plot -1, 3. So I'm going to start at my origin. I'm going to go -1 and then 3. 1, 2, 3, and there's where A sits. For B, it's -3, 4. So I'm going to start at my origin again and go -3, 1, 2, 3, and then I'm going to go up 4, 1, 2, 3, 4. And there is point B. Point C is at 0, -2. So 0, I'm not going to go anywhere, right or left, but I am going to go down 2. And there is C. D is at 3, -3. So +3, which moves me to the right, 1, 2, 3. And then -3 is down 3, 1, 2, 3. And I'm sitting at D. E is at 2, 0. So I'll go to the right 2, 1, 2. But I do not go up or down at all. So that is my point E. And point F is at -2, -1. -2, and then down 1 would be my point F. One of the main things that people want to make sure you do is you're graphing right or left first, and then you go up or down secondly. We're going to plot each point on the graph. Why don't you go ahead and give that a try. I'm going to press pause once you plot that on a piece of graph paper that you have, and we'll see how you did. Okay, here's the points plotted. See how you did. Now the next slide here is we're going to also press pause. I want you to plot those 2 points and connect them to see how you do on that. All right, how'd your line look? A couple things I would do a little differently is I would get some arrows on the end of those to indicate that the relationship does continue on. All right, let's get started after our review. So our objective is to find rates of change from tables to find the slope. We can use diagrams and tables to do that. Our essential understanding is you can use ratios, okay, which is very important here to show a relationship between changing quantities, such as vertical and horizontal change. The rate of change shows the relationship between 2 changing quantities. When one quantity depends on the other, the following is true. So our rate of change is the change in the dependent variable to the change in the independent variable. So as one changes, so does the other. It's our job to go ahead and find that pattern and indicate that as a ratio. So we're going to find the rate of change using this table right here. The table shows the distance a band marches over time. Is the rate of change in the distance with respect to the time? Is it consistent? What does the rate of change represent? So we got to look at the rate of change of the change in distance and the change in time. I'm going to calculate that right here. So I can find that out by comparing these two here. So I can see that 520 minus 260 is going to be 260. And then I want to compare these two as well, representing my change in time. So it's going to be 2 minus 1, which is going to be my 1. And I can see that my rate of change from one row to the table to the next is 260 over 1. In problem 1, do you get the same rate of change if you use non-consecutive rows of the table? So I want you to try this, but use like, let's jump from 1 to 3. I'm going to press pause and then check your math. When I jumped in time and also jumped in distance, it looks like that my change still does show itself here. So that shows us that we don't have to do a sequence from 1 to 2 or 2 to 3 or 3 to 4. We can jump them, and if it indeed is linear, it will, the rate of change will show itself. The graph of ordered pairs, time and distance, in problem 1 lie on a line as shown at the right. The relationship between time and distance is linear, which means it does create a line. When data is linear, the rate of change is constant. So what happens over time, we can see that in a table and specifically in a graph. Notice that the rate of change as found in problem 1 is just the ratio of the vertical change. So the vertical change, our rise, or the horizontal change, or the run, between 2 points in the line. The rate of change is called the slope of a line. So the slope of the line is our vertical change, which is our rise, or horizontal change, which is our run. So we call that rise over, oh, I should spell over, right? Over, there it is, run. And we're going to try that out a little bit. So our rate of change is actually our slope. Finding slope using a graph. What is the slope of each line? First of all, we got to look at how much it rises. So on graph A, it rises up 2, and then it runs 3. So because my slope is rise over run, it rises 2 and runs 3. So my slope would be 2/3, the slope of the line or my rate of change. On graph B, you can see that it doesn't rise, but it drops some negative numbers. So we would say down 4, and then it still runs positive, so it runs 5 units. So because my slope is rise over run, I would indicate my rising as a negative number. So it rises -4 and runs 5, and I would indicate that my slope being -4/5 on this one. All right, why don't you press pause and see how you do finding the slope using 2 points in the line. Look for the rise over run ratio. All right, let's see how you did. The slope for A is 2/5, and the slope for B is -1/3. And you are going to get the same slope if you use different points. Now, if you notice, the line in part A has a positive slope in that it slants upward. So as we travel this way, it does go upward. And B, because graphs are like a story that you read from left to right, as the story is being read, as this information is being calculated, the slope is actually declining, or we would say that has a negative slope. So positive slope goes up, negative slope goes down as you read from left to right. The story of the graph. You can use any 2 points on a line to find the slope. Use subscripts to distinguish between the 2 points. In this diagram, x1 and y1 are the coordinates of point A. x2 and y2 are the coordinates of point B. We use this to keep track of it. And we're just trying to find the slope of line AB. We're going to use the slope formula. Because slope is rise over run, we're using 2 points. We want to find out how much it rises. So if we don't have a graph, we can use this formula. Y2 minus y1, it's going to tell us how much it is rising. And then we use x2 minus x1 to tell us how much it's running. Now you can use either point. You can start with this point here minus that one, or you can go the other way around. Just you have to be consistent. In this case, you have to be consistent which one starts your problem. Finding slope using 2 points. What is the slope of the line? So what we just talked about, we're going to practice this out a little bit here. So I'm going to use my formula. I'm going to check the change in y. So I'm going to start with -2 minus, my -2 minus 0 over my change in 3 minus my change in -1. And I'm going to simplify this out as -2 over 4 because I add those together. And this becomes -2/4, which simplifies down to -1/2. That's the slope of my line. Why don't you give it a try? What's the slope of that line? Use your formula and then try the reasoning. Press pause. All right, let's see how you did. One thing to keep track of here, and you can see in this problem here, is just keeping an eye on those negatives and what my value is really doing. -1 minus 3 is -4. And after I finish, when I simplify, and here's my -4, and when I simplify it, I do want to throw my negative in the front of the entire slope. Finding slopes of a horizontal and vertical lines. What is the slope of each line? I'm going to just go ahead and use my formula. So I'm going to have you use my 2, so 2 minus 2 over 2 minus -3. I'm going to play this out. 2 minus 2 is 0 over 5. 0 minus 5 is going to be 0. So my slope on this one is 0. For B, I'm a little bit different. So I'm going to use my 2 points here. So -2 minus 1 over -2 minus -2. And when I play this out, I get -3 over 0. And anything divided by 0 is undefined. So we would say that this line is undefined. It has no slope. Actually, it's not that it has no slope, it is undefined. The horizontal axis, though, right here, this one, the slope is 0. All right, I want you to give it a try here. Press pause, use your coordinates, use your equation, and find the slope of the line. Excellent. How'd you do? This one right here shows us that it is undefined because we can't divide anything by 0, not even a slope. And this one indicates that my slope is 0. So we can see that on this one right here, we have a horizontal line playing out in B. And on A, we can tell that this must be a vertical line that is playing out. A little bit of a summary here to keep an eye on things. When a line has a positive slope, it slants upward from left to right. This would be a negative slope. As we move from left to right, kind of that downward mark. A line with a slope of 0 is horizontal, and a line that's called undefined slope would be vertical. All right, I'm going to go and dance till my elbows hurt.